Good morning, everybody. Here we are, ready for some more maths on Thursday. So we'll crack straight on with our Fab 4. So we're using known facts today to multiply decimal numbers. Now, if you get through these really quickly, I want you to think of the deepening question about what you notice about the answers to question 1 and 4 and why you think that's happening. So pause the video, come back in 4 minutes. So here we go. Our known fact for this was 18 times 3, which was 54. That's what we're using to base the rest of our answers on. 18.0.3, which is 10 times smaller, should be 5.4. Now, when you multiply by 0.03, that's 100 times smaller. So you should get 0.54. And this was the interesting one because 180 is obviously 10 times bigger than 18, and 0.3 is 10 times smaller than 3. So actually our answer was 54, and our reasoning is there because 180 is 10 times larger, 0.3 is 10 times smaller. It balances out to give the same answer as our known fact that we began with. So we're continuing today. Our WALT is to multiply one-digit numbers with up to 2 decimal places by whole numbers, and we're going to use known facts to help me multiply the decimals and interpret diagrams to help you multiply the decimals as well. And we might look at multiplying fractions by a number and integers to help us too. Now here's our discover. This girl here is building a fence. Now she wants to ultimately have a nice long fence, and what you can see on the picture is one panel. You can see that one panel is 1.2 meters wide. We don't know the height, but we know that each plank of wood has a width of 0.3 meters. Now, our first question that we're going to think about today is how can you calculate the height of the fence panel? So let's think what we know here. We've got one fence panel. There are 6 planks of wood. Can't we see that, can't we, on the picture here going down? There are 6 of them, and they are all 0.3 meters wide. So have a go at writing down what you think the calculation is to calculate the height of this fence. Write it down. Okay, so our calculation is 6 times 0.3. Now, in order to answer this, like with our Fab 4 warm-up, we can use our known facts to help us. Now, our known fact is that we know 6 times 3 is 18. Now, we're doing 6 times 0.3, which is 10 times smaller. So that means 18 needs to get 10 times smaller. So the height of that fence panel is 1.8 meters. Okay? Okay, so now we're going to take the problem a little bit further. We're going to imagine now that this girl is now continuing to build her fence going across, and she wants to have 7 panels of fencing. Now we know that the one panel is 1.2 meters wide, okay, which is the same as 120 centimeters. Now, if the whole fence is made of 7 of those panels, how long all the way across will it be? What will our calculation be? So have a think, write down what you think to calculate the whole width of the fence. If there are 7 of those panels, what will the calculation be? So here it is. We're going to calculate 7 times 1.2. Now there are 2 good methods that I'm going to show you how to tackle a multiplication when it is like this, where you have got something in the ones column. Now, the first method, we can again use our known facts like we've done before. So our known fact here would be 7 times 12, which equals 84. Now again, 1.2 is 10 times smaller than 12, so we need to make our answer 10 times smaller, so our answer would be 8.4 meters. Now another method is to partition our decimal number. So what we would do 2 steps. So first of all, we would do 7 times 1, which would give us 7, and then we would do 7 times 0.2, which would give us 1.4. And then what we've done there is we've partitioned the 1.2, we've split it into 2 bits and multiplied them both by 7. Now then with our answers, we need to add them together, and we would get the same as the other method, 8.4 meters. So with these, I want you to look at the different methods and decide which one you prefer to use. Now, in your Power Maths books today, there's a bit to begin with where you're looking at diagram representations and having to think about what calculation that is showing. So I wanted to show you some on here with our think together so you get into the idea of what that means. So here is an example. So you've got 0.1 in an array. Now you can see, you could look at this in two ways. I'm going to show you both ways because often they ask for two different ways in your book. Now I'm going to look vertically. So what I'm thinking here is if I look vertically, within that group going down in that column, there are 3 lots of 0.1. So that means I've got 0.3 in total. Now I have then got 0.3, if you look carefully, how many times? I've got it 4 times, which means I'm multiplying it by 4. So have you seen how I've done that? I've thought, right, there's 1, 2, 3, 0.3 in total, and there's 4 lots. So my calculation is 0.3 times 4. Now I'm going to think of my known fact, which would be 3 times 4 is 12. But because I'm multiplying by 0.3, I've got to make it 10 times smaller. So my answer would be 1.2. Now here's a different way of looking at it. Now we could look a bit going across horizontally in a row. Now this time, how many lots of 0.1 are there in a row? There's 4, isn't there? So you've actually got 0.4 in each row. And how many times are there rows of 0.4? Well, there are 3 times. So that means we're multiplying by 3 wholes this time. And again, our known fact, we would have 4 times 3, which is 12, 10 times smaller, which is 1.2. So you're going to get the same answer. It doesn't matter whether you think of them in vertical columns or horizontal rows. Either way, you'll get the same answer. But Power Maths will sometimes ask for them written to be both way rounds. In fact, if you want to, what might be a good idea is if you open your Power Maths book now and have a look at question 1, pause the video, answer question 1, and then come back, because that is all linked to what this is just showing. Now, there are other ways of representing. Sometimes you might have it like this, just there's some circles and it tells you the width of each circle. Each one is 1.3, therefore that's our first number in our calculation. And how many are there? There's 4, so we're doing 1.3 times by 4, which is 5.2. Our known fact would have been 13 times 4, 10 times smaller, gives us 5.2. Now, this is like a spidergram, which is showing you the known fact in the middle and how you can use that known fact for all those different types of calculations. So I recommend, we know, looking at it, 18 times 4 is 72. So I think it would be a good idea to pause the video, see if you can have a go at writing the answers to A to D on a piece of paper or anything that you can jot it down on, and then come back when I show you the answers. All right, so I hope you've got on okay. So part A, we can see that the 1.8, that's 10 times smaller, so the answer will be 7.2. Part B has got 4 being 10 times smaller from our known fact. So again, the answer will be 7.2. Part C is a little bit like one that we did in the Fab 4 warm-up. The 18 is actually now 10 times larger, but the 0.4 is 10 times smaller. So our answer is going to be 72, the same as our known fact, because there's been a compensation, bigger on one side and smaller on the other, so it's balanced out. Now 18 times 0.04, we can see that 4 is 100 times smaller this time, so our answer is going to be 0.72. Okay, hope you got on all right with that. So today you've got pages, oh, I haven't put the whole number on here. It's pages 24 to 26 for today, and it's called multiplying decimals. Now, if you've done it in stages whilst the video's been going on, that's been fine. Another thing I wanted to let you know is that 2 things really. If you find some of the Power Maths really difficult, don't think that we're expecting you to complete the whole book before you send a photograph of what you have done. If you've managed to say tackle 3 of the main questions and then you're a bit stuck, send me a photo of what you've done so far, and you can always send me a message to say, I'm a bit confused with these ones and I can give you some help. There is no harm in not doing all of it. That doesn't mean I want you to think, oh, well, I'll do one and that will be enough. I want you to try. If you can get through it, then great. But if you are finding some things challenging and you've spent half an hour, 45 minutes on your work, that's enough, isn't it? Send in what you've done and I will give you any help if you need it. On the other hand to that as well, If you find that you're whizzing through this work, some people did yesterday, and I sent them a message saying, I've got some deepening activities. Now, I'm not putting that up to bombard everybody with too much work, but if you feel that you have completed the work really easily, send me on your, when you take your photo and put it back onto your portfolio, put a little message to say, ask me for the deepening activities, and I can then pop it onto your portfolio for you to go a little bit deeper into the work that we've been doing today. Okay, I hope that all makes sense. I really don't want anybody worrying if they're finding things too hard, too easy. Please just get in touch with me and I can help you on either way. All right, have a great day and I'll see you again tomorrow. Bye-bye.